Good morning, good afternoon, good evening. Welcome everybody to the fourth session of the World Bank Global Data Facilities Foundations in Mobile Phone Data for Policy training course, with a focus on designing and implementing mobile phone data initiatives. We go over now to today's instructor, Erki Saluvier from Positium. Over to you, Erki.
So good morning, good afternoon, good evening, everyone. My name is Erki Saluver, and I do try my best to give you the overview of the general understanding of the mobile phone data pipelines. So this session will cover the following topics. So we will go over all the different stages that one mobile phone data pipeline has. We will talk about what are the inputs within the data pipeline regarding the data. We will briefly go over so what is the privacy by design aspects of the data pipeline and how to distinguish between of them. And finally, we will talk about the data models, the structures, so how the mobile data pipelines are built up based on where the processing is happening. So without holding us back, let's start. So in this session, we will cover the stages of mobile phone data pipeline. There are altogether 5 main stages of the data pipeline. Each of the data pipeline, if we want to get from the mobile phone data to the statistics, starts with data collections, where the data is extracted from the mobile network operator. And I will cover each of these collection steps also in the upcoming slides. When the collection is done, then extract, transform, and load stage will start, where the data is transformed into pseudonymous form, important for the data privacy aspects. And also the agreed data structure, the data is turned into agreed data format, and the first quality checks of the data are done. From this stage, the main stage is followed, which is the data processing, where all important aspects of the mobile phone data steps will happen, meaning the data is cleaned, the data is filtered from errors, the data is advanced into more into many other statistical indicators. There are some advanced methods as well in the processing to increase the quality. I will cover in the later stages. After the processing, the data is then aggregated in space and time. And finally, in the last stage, the statistics are formed in a way that we would represent the overall population. So the bias is adjusted and the scaling is happening. Also, the quality assurance happens at the last stage. So this is briefly the introduction into the stages, but I go over them one by one. And in the next upcoming slides, you will see on the right side, so in which stage we are. So from the collection to the extract, transform, and load. Then the processing is divided here into 2 stages, so cleaning, and then the processing itself, aggregation, and then the scaling dissemination is the last one. So let's start. So how does the collection within the mobile phone data project happen? So it always starts, the data generation starts when someone uses a phone. So in our example here, we will use where people are making phone calls and generating events to the mobile network operator. So when a user makes a phone call in location X, then they are connected to a nearby cell tower, and their call is routed through that cell tower or cell antenna. This antenna information is then routed to the network operator and logged for later stages. When we see that this person is making another call from location Y, then again, this call is routed now through another network antenna and stored in the same mobile network operator log systems. This process is going over whenever you are actually using your phone, either making calls in the case of the call detail records, also when you are using data networks, data for browsing internet. So everything happens in the same way. And this is how we generate a lot of location information to the mobile network operator side. And what is stored on the mobile network operator side is mainly three attributes. So we have some sort of subscriber identity stored, usually a phone number. We have a time of this event, and we have the antenna or cell ID through which one the activity was routed through. So you could imagine that when we think about how many phone calls we make during the day, so the average is around 4 to 7, so sending, receiving per day. But because mobile network operator has millions of users, then a lot of like billions of records are basically with this structure generated into the mobile network operator log files. And the structure of the data looks something like that, very basics in essence, but a lot can be done with this very basic data structure. We'll cover again on upcoming slides. Very important here is to understand that this data needs to be collected from the mobile network operator side. And then what is important is that this data needs to be prepared for the extract, transform, and load stage. So we need to agree on the data structure, how the data should look like. How do we format the data? How do we pseudonymize it? I will cover these things here. So before transferring the data outside of where the data is generated, we have to agree what is the agreed table format. So, and also not only what kind of attributes we collect from the mobile network operator, but also in which format exactly they are. So how the time is represented, how the subscriber identity is described, etc. Also importantly, there has to be happening a process called pseudonymization. So pseudonymization is when we lose the identifiable indicator about the subscriber, meaning, for example, the exact phone number with code that doesn't reveal the person identity. So it's pseudo codes for ourselves. So the mobile network operator is doing the pseudonymization so that anyone else in the later stages wouldn't know who this data belongs to. But the data is still sensitive. We'll cover that in the privacy by design section. In this preparation steps, also additional attributes can be extracted from the mobile network operator. One very important attribute is mobile country code, or MCC, which is in order to distinguish different tourists when we talk about tourist statistics. Also in that stage, the data quality checks have to be made, because it's much easier to make them where the data extraction is happening, not in the later stages. We'll cover some of the quality assurance checks also. And the data needs to be minimized also, because as I said, the data load is very big. You have billions of records. You have to transform them either into binary format or back them into some other format so that the data would be minimized. And finally, in that step, also the encryption has to happen. Because the data should never leave its place without encryption. So what will happen next is that transmission will happen. So the collected data from the mobile network operator would go to the data processor. I will show you later that the data processor can be mobile network operator itself as well. But even within the mobile network operator system themselves, the data processing never happens at the same place where it is collected. So even within the network, still there is a transmission, and that has to happen in a secure manner. As said, the data needs to be encrypted. As the data volume is very big, the data size has to be taken into account. So one way how to overcome that, getting here very technical already, but is that you can partition the batches for the transmission efficiency. The batch could be, for example, you divide the data into days, or you divide the data by subscriber groups or location groups. In this stage, also very important is to use strong user authorization, that only the people who can have access to the data have the access. And obviously, secure transfer protocols have to be used. One important step from our learning experiences from the past is that you have to apply here also then data integrity checks, so that you would make sure that nobody has dampened your data in between of sending out the data and receiving it on the other side. When the data is transferred and loaded into the new system as it is already formatted, we get to the data cleaning steps. Data cleaning is very important. Otherwise, you would end up with possible result, which is called garbage in, garbage out. So we have to make sure that the data is cleaned before the data processing steps. So why do we do that? The most important thing is that wrong data can give way to wrong decisions and bad conclusions or poor analysis. So, and that is caused because there are many data errors when we talk about mobile phone data in its raw format. And one key aspect of actually cleaning the data is something that you reduce also the data size by cleaning out data which is not needed for actual processing. And as I said, the data loads are very big. Keeping them minimal stage would give the possibility to optimize your processing costs. So how the data cleaning is happening? I give you some of the cleaning filter examples that have been used, but actually there are many cleaning filter examples that can be built based on your specific use cases. So the most common cleaning filter is to eliminate Internet of Things devices. You could think of home security systems, or for example, those trackers that are put onto the trucks that are moving around. So these are not people, and we need to exclude them from the data. We also know that the Internet of Things device, the number of devices is increasing. So it's an increasing problem to deal with when we do statistics about human mobility through mobile phone data. But there are other errors that must be cleaned as well. So one example is from maritime and aviation. So you all know that when you take off or land your plane, you are asked to switch off your phone. Little secret, not all people are doing that. Well, actually, it seems that very many people are not doing that because when the planes are taking off, they are still communicating with the cell towers on the ground. Well, you might know that you can actually browse even internet on the plane. So meaning that we have to clean that data. I have an example from Indonesia, where one of their islands is very close to Singapore airport, and a lot of Indonesian cell towers collect data about people in their landing in Singapore. So for a mobile network operator, it seems like there are many foreigners on that island, but actually they are in the air. So you need to filter those out. The same goes for the, for example, cruise ships on the sea. It's the same thing. They are going by the coast, and it seems like from the mobile network side that people are on the land, but actually they are on the sea. So you need to clean them out. Also, mobile network operator generates ghost events. So sometimes people appear to be in two different places. You need to clean them out. Accidental roaming is something that you might have experienced yourself as well. When you're close to a foreign country, your mobile phone might switch to the other country's network, although you haven't crossed the border. This is called accidental roaming. And again, the other country might see you as an incoming tourist, but actually you haven't crossed the border. So again, an example where the data needs to be cleaned. As said, there are many other examples. But when the data is cleaned from possible errors, we get into the processing stage, which is the most important part of the mobile phone data pipeline, because this is where the value is really created. So to recap, first of all, the data cleaning takes place either from one mobile network operator or several. But then something which we call core data model should be applied, that the data is transformed into a stage where you could apply domain-specific algorithms to end up your desired statistics. So we could see that from the core data model, you might want to get tourist statistics. For that one, you apply tourism algorithms. The same goes for the population statistics through population algorithm, migration, transportation, any other domain you deal with, you have to develop these things. But first comes the core data model that applies to the all models, and then you end up with different statistics. Why I'm talking about that is actually because you have another option. So there are basically two models, centralized and decentralized model in that sense. So core model on the right side is the centralized model, and decentralized model is on the left. And there are mobile phone data projects which follow both of these models. But the distinction is that on the left side, the decentralized is where you have a methodology for each specific domain. So for the tourism, you have one methodology. For mobility, transportation, you have another model. The problem is that you end up with two different results that might not be any more comparable because they have different methodologies. With core data model, you have this positive side that in the center you have the core data model, and only domain-specific logic is applied on top of the core model so that the results would be comparable at the end. Just something that bear in mind, because at the end it feels like it's easier to start with this decentralized model, especially when you have only one domain in Radar. But at the end, you might end up with this problem that these different domains are not comparable. So this is why I'm advocating clearly for the core data model in the center. Within this core data model, what happens? So one example is that continuity model is built. I will briefly explain you what is continuity model here. So we have an example here to understand you. We have four different people who are making call events. So black ones are in location A, and then with gray ones are in other locations. So making call activities. And this is a basically timeline from left to right. If we want to now count how many people are in this location A within particular time frame within these blue brackets. So if we have just the event and we would calculate how many people are, then in that particular example, we would count 2. Because you can see that the person number 3 and 4, they don't have events during that time. So this is why it's good to apply continuity model, where you extend the presence in one location throughout the period when the person is there, and some extra on top of that. So if we apply the continuity to location A in this blue area, you would see that when we would do the counting now, we would end up 4 persons, as was this example given, so we get the correct result. This is especially important when we talk about call detail records, so that this kind of methods are applied, or when they are not applied, you would at least know that that kind of underrepresentation is happening in your data. So another thing, what happens when you apply this continuity model is that then you can divide your data into stay and move sections. It's very easy to understand. When we had this continuity example previously, so one person staying at one location from time 1 to time t+1, this is one stay. So it's staying in location A throughout that time. And of course, we apply to different location, we get different stays, and between of those stays, when a person moves, that's a move section. So we would kind of build this continuity model that there are stays, and in between of the stays are moves. What that allows us to do is that we can get into the transportation statistics. And for example, when we know that person is going from location A to location B, we can, for example, route that down to the road network and end up with a probable route that the person might have taken, which is basically a probabilistic accuracy improvement of the mobile phone data. One example of this processing, core processing step. But I think the most important part in almost any mobile phone data project is to detect meaningful locations such as home, work, free time, etc. locations. So locations that are important for people. For this purpose, a model should be built based on spatial temporal patterns of each of the subscriber. A very easy example would be that in order to detect home location for a subscriber, we could just see where this subscriber spends most of their nights. So that is most probably home location. Similar pattern detection can be applied to work, but this could be also extended into more advanced models where, for example, you could also detect night shifts, etc. When we detect the most meaningful locations for a person, we also can define then usual environment. So the environment where a person usually stays in homework, their secondary home, etc. Why is it important is because through that we can detect domestic tourism trips. So when a person leaves the usual environment, that is by definition, according to the tourist statistics, a tourist trip. And this is very beneficial step, again, within this core model to detect, to be able to detect tourist trips at later stages. Identifying usual environment, there are different ways how to do that, but you can learn more about detection of meaningful locations and usual environment in the second module of this training. Also, important part of the core methodology is to improve the accuracy of the locations. So I gave you already example through the routing for the move sections, but you can also improve the probabilistic locations for the stays. So for that part, usually additional data sources are taken into help. So one example is to use buildings data and land use data, because people tend to be mainly in buildings or in high visiting land use areas like important parks, etc. So what it allows us is that although we only know that the person is somewhere in the coverage area of a cell, we can actually assign them into the probabilistic buildings, which in essence would avoid, for example, putting people into the rivers, lake, and areas where they can't be. So again, this is a method to improve the location accuracy, as actually was this continuity model, a method to improve the temporal accuracy. So important thing of core methodology. There are many other processing steps that can be done. I would explain some examples from here. So one example is functional midnight, because you could, when we talk about tourism trips, then if a person has a plane at 2 a.m. during the night when they are leaving a country, then we don't consider these last 2 hours as a next day trip, but rather part of the previous day trip. So that's why a functional midnight should be used. Usually it's at 4 a.m. or 5 a.m. So you're basically shifting the nighttime in the data. When we talk about goal detail records, because they are not happening that often, it's important to put people back home when, for example, the last call activity was within the city, not where they usually reside during the night. It is important to have methodologies to detect the trips, either domestic or tourist trips, if you want to do tourist statistics. You have to extend for that purpose also the trips until entry and exit gates in the country. Already talked about routing the move sections. But yeah, there are many other things that you can apply. For example, just to pick one from here, the modal split of the data. So what kind of transportation mode people use based on the patterns, how people moved within a country. So how this cleaning and processing looks data-wise, I can give you an example here. This is actual data from a project that was done in Indonesia. And they applied both the cleaning and then the core data methodology steps to get the inbound tourism numbers. So here you can see that altogether there were 8 million tourism trips at the beginning when the data cleaning and processing happened. And through each of the stage, the amount of data was either cleaned out until the less than 3 million trips was the actual statistics at the end. So most of the data was cleaned because they were happening too fast. This is the example of this, how to detect the planes landing in Singapore. But also through other filters like removing the accidental roaming or cleaning the data when people are at the sea. So a good representation, again, how the size of the data goes smaller and smaller, the more steps you go through. And also that if you don't apply these methodologies and do just a simple count, you would know that there are 8 million tourist trips, but this is not correct because as we can see, we had already cleaned them through these stages. After the cleaning, then and processing, the data needs to be aggregated. And aggregation mainly happens on spatial and temporal dimensions. So, and why I'm talking about it here is that it is very important to already think in advance from your end perspectives of the mobile phone data statistics. So what kind of aggregations do they need? Because the possibilities how the data could be aggregated is really endless. So the most common spatial aggregation methods are local administrative units or administrative units. So either you do it on the regional or country or really village level. There is also spatial interpolation into the grids as one common way. But then you also have to bear in mind that each of the spatial aggregation has to be also agreed on what temporal aggregation it needs to be done. Is it the daily average in a year, or it's a quarter average, month average, or it's a representation of an hour? So it's something again that you need to pre-plan. But then comes the specifics also into what kind of indicators you want to aggregate the data to. So, for example, when we talk about tourism statistics, then the country of residence is very important to understand. So from where people are from, and then you need to understand also what you want to measure. Do you want to measure how many days those people in that day in this region from that country spent, or you want to know how many visits they started in that same kind of division? So that's why the aggregation step is important to understand all these different dimensions. One example how the aggregation happens and why these spatial interpolation methods are important. Here you have an example of aggregation into local administrative unit. I think it's on level 2, so it's municipalities from Estonia, and we can see here that this green area is one cell coverage area. So this is the actual coverage area calculated by the mobile network operator. So when we calculate tourist statistics for this particular antenna or cell, these tourists can be anywhere within this area. But this area, now we can see that covers 3 different administrative units, 100, 101, and 102. So how to distinguish between of them? Different methods, again, have to be applied. But why I'm showing you is because it's important to think already in advance. So what processing steps you go through. One possibility is to use just the area average, but the other one is, as I explained, to go with a probabilistic spatial interpolation way. Another example is spatially you can aggregate the data into grids. So this is something here on the slide. You can see how aggregation into the adaptive grid looks like. So where the grid size depends on how many people are in that area. So the last stage is basically population scaling and bias adjustment, because when we calculate mobile phones, even when they are human related, then if we take all the mobile network operators together, then actually we end up with more phones than there are actually people in a country, because some people do have several phones. So you have issues with over coverage and under coverage, and you have to have a model in place to end up with accurate statistics. So this is a very basic methodology, but actually very hard to do because there are very little baseline or ground truth data to apply to. So usually just the market share of the mobile network operator is taken into account to overcome over coverage and under coverage in mobile phone data before the statistical dissemination. And in this stage also, if you do this bias adjustment, then the output data quality assurance has to be performed to ensure the accuracy, completeness, and reliability of the data. Important factor here is also that data protection measure like statistical disclosure control also has to apply, especially when you go in very small granular level in space and time with your data. So that, for example, tourists from Estonia in Greenland, they wouldn't be shown on low level, because basically you would disclose particular traveler patterns in that regard. How does it look like, this bias adjustment? Here is an example from Gambia and their model. So they apply this methodology on district level, and they have the number of subscribers in each of the district, and they use it as a base to correct the number that we get from the mobile phone into the general population statistics. Finally, the stage is dissemination, where we would publish the results either as reports, tables, maps, dashboards, or APIs. On the right side, lower here, you can see that statistics, the Central Bank of Estonia is publishing tourism statistics in Estonia since 2009 only as table format, and that actually works fine. Of course, you can do nice visualizations. On the left side, you can see commuting patterns visualized, and on the right side, one day in a city, what is the traffic levels on different roads. But I must say that usually the reports and tables are the most useful ones, so don't overthink also with the dissemination part. So in this session, we will cover data inputs, understanding the data characteristic that goes into the processing pipeline. As said, it is important to understand from which part of mobile network operator you get the data, and it is important to agree in which format also it's possible to get this data. To make that process easier for you, we recommend to do mobile network operator data availability checklist, where you would ask what data do they have available in which format, and what is the data retention policy, so how much time in back you can go in order to derive that data. So this is clearly very important in order to have the visibility of what can be done in the data processing stage, and also what kind of aspects affect your data quality. Important characteristic of the, data is, in order to understand that there are actually 3 different types of data within the mobile network operator: inbound, outbound, and domestic. Domestic data, I give you an example from Estonian perspective. So Estonian mobile network operator, when they see Estonian subscribers within their network, this is called domestic data. So within their own country, doing phone calls using the phone, this is called domestic data, which is important to publish, for example, population statistics, mobility statistics, but also to detect domestic tourism. When foreigners come to Estonia, they would do something which is called roaming. So they would roam in Estonian mobile network operator. And this is why this data is called inbound roaming. mobile phone data or inbound tourism data. And obviously from that one, we can detect tourism statistics, but also mobility statistics. And finally, when the Estonians go abroad, they start roaming in other networks, and this is called outbound roaming data or outbound tourism. As I said, there are three main data attributes in mobile phone data: the subscriber identity, the timestamp, and then the location attributes. Usually they are the antenna ID or cell ID, but for example, in the outbound data type, it could be also a country. Within the inbound, it's important to understand also that you have two location attributes. So one is where the person is within doing the event, and the other part is where they are from. So this is the mobile country code, usually is what reveals their country of origin. When talking about the subscriber identity, there are different ways also how you could extract it from the data. So mainly in mobile phone data project, the international mobile subscriber identity is used, which is IMSI. This is the most common one. This is a number which usually people don't know, but each of your SIM card actually has this number, and all the network recognized you through that one. What we know is something called MSI-SDN, which is the basically phone number that we call to. But these are actually two different numbers assigned to one and same subscriber. There is also equipment identity, basically telling you what is the phone itself. And of course, mobile network operator has their own customer ID as well. You could have all of them used in a project, or usually the IMSI is preferred way. Again, important just to know that there are different ones. Also regarding the network antenna data, that's why I said it's important to build this mobile network operator data availability checklist in order to understand what data is available, because you could just have the location of each of the antenna available, or you could have the coverage area as I showed you on the map, or you could have some attributes like power, azimuth, angle, and height in order to calculate yourself the coverage area as a processing model step. Actually, a mobile network operator has a lot of other useful information available. They often have socioeconomic data available, like age, gender, preferred language, and address. But the data quality needs to be checked before use. It can be good, but it can also have some issues. But anyways, for the statistics generation, this is very valuable. Also, for example, mobile network operators calculate average revenue per user, which can be used, for example, to detect the income class and, as an example, do poverty mapping, etc. So again, important to go over these what is available. The B number is when we talk about call detail records. B number is when it is also stored to who did you call to. So it's something which is valuable in the case of disaster situation analysis. So where people call to, what are the kind of connected areas, etc. Or do the segregation analysis, for example, again, very beneficial for these kind of academic purposes. Now, in this section, we will cover privacy by design main concept when building a data pipeline. This is not a very extensive part, because basically, in order to understand the privacy by design, I recommend you to understand that there are 3 different tiers of mobile phone data inside the processing pipeline. So I go over them one by one. So the tier 1 data is the initial raw data, which is not aggregated and contains the personally identifiable information. And it also includes the business confidentiality information from the mobile network operator. So this is the most sensitive data. The tier 2 is when the data is already pseudonymized. So personally identifiable information is removed. And the data does have some business confidentiality information, but some of it already might be removed in tier 2. And in that stage, also the data is sensitive, but not as sensitive as in tier 1. And the tier 3 data is when the data is already aggregated, so no personally identifiable information is available and no business confidentiality information is reviewed. If we look the tiers in the data processing pipeline from left to right, then we can apply this traffic light system for each of those tiers. So the tier 1, the red one, with high sensitivity is, as said, personally identifiable informations are available. This data usually resides only on the mobile network operator side, and very strong access controls, encryptions, etc., has to be applied for that kind of data. The processing actually happens usually within the tier 2 because the data is pseudonymized, so no direct personally identifiable information is available, but some business secrets are still there, and still safeguards has to be applied. The tier 3 is the statistics which are ready to be published, and this is the green light, so good to go and shared with the others. But basically, privacy by design has to go in order to understand where you are with each of the tiers. Which brings us to the final session of today's lecture. In this session, we will talk about pipeline models, where different pipeline processes are located and what are the differences between of these models. In essence, there are 2 main data processing models when we talk about it in the perspective of processing pipeline. So one is aggregation is happening at the mobile network operator side, where mobile network operator is mainly responsible for data processing. And the other one is where the aggregation is happening at the government side, and government stakeholders are responsible for the data processing. There is a submodel in between of those, where mobile network operator is responsible for technical infrastructure, but the government body or technical service provider is responsible for the processing of the data. Each of those models have implications for the costs, needed measures, and security, privacy, and data protections. So I will show you how they look on the data processing pipeline. So the first model, aggregation at the mobile network operator by the mobile network operator. So this is where you can see that all 3 tier data are happening within the framework of the mobile network operator or the data provider. We see here 2 data providers that would do the extraction, processing, and aggregation within their premises. Only the aggregated data is then collected by the government, and then the combining of these two operator results are done before dissemination activities. Examples of countries that are using these models are Finland and Austria, where they are both really hoping that the mobile network operator is very rigorous throughout the process of aggregating the data. This is the easiest to start with. I will tell the pluses and minuses of this in upcoming slide. So the MEAD model is where the aggregation at the mobile network operator is done by the government entity or then technical service provider. So basically here the a special sandbox is built where the processing is taking place. Basically the government has access to this part, and they have a good overview of turning the tier 1 data to tier 2 and to tier 3. So it's a good control for the government, and otherwise the aggregation would happen on the tier 3 level at the government in later stage. And then the other model is, okay, sorry, I forgot to say some examples where this is applied. The example countries are Ghana, Haiti, and Indonesia, where this model is applied. Lastly, the aggregation happening at the government. This is where basically the tier 1 data or pseudonymized tier 1 data is transferred securely to the government, and all the data processing steps happen at the government side. And what it allows is that you can aggregate, add operator data on the tier 2 level, making some of the data quality checks possible that otherwise are not possible. For example, detection cross roaming between of the mobile network operator inbound tourism sites. So what are the advantages and disadvantages of each of the models? So when aggregating at the MNO by MNO, so it has the highest data security and lowest risk of accidental disclosure, because mobile network operators are already used to handle that kind of data. And it has a higher confidence for the mobile network operator as well, because they also care about their subscriber data. The disadvantages is that it does have much higher cost for the mobile network operator, and usually that also is visible by the price that they ask. And it also usually has a lower control confidence for the statistical authority, especially when you are trying to get the data from different mobile network operators, because applying the same methodology in different operators, that's really hard to do. And usually the data is lower granularity level, because just overall the process is harder. When the government has a sandbox within the mobile network operator, this has higher control confidence for statistical authority. It has, again, higher data security because the data doesn't leave the mobile network operator. But on the disadvantages side, there has to be a very strong partnership between stakeholders, and the technical capacity needs to be built in each of the mobile network operator separately when you want to aggregate them together, which increases the cost. And finally, the aggregation at the government, the advantages is that you have higher control confidence from the government side over the methodology. And potentially there is less disruption to statistical production when operators enter and exit the market. But on the disadvantages side is that the statistical authority needs to invest in IT infrastructure, and it needs to invest also into the security systems, because there is now higher privacy disclosure risk as the data is basically moved outside from the mobile network operator. And legal frameworks might be much harder to set up as well. Actually, there are many characteristics how you could kind of value between of these different models. So here I give you some of as examples, so how we can compare these different models. So one by one. So first, who is responsible for the data processing? Green meaning that from the government perspective, this is better, and red meaning from the government perspective, this is an issue. It is an issue because the mobile network operator has, in the first model, much better overview, and it's much harder to put them to do the processing as the government really wants, as there is communication. The granularity of the data usually is much higher when the data is much closer to the government. But the perception of risk to privacy and business confidentiality is much higher when the data is much more closer to the government. So it's the opposite. So range of potential statistical indicators that can be derived, again, usually increases the more government has access. The ease of verifiability and statistical quality control, again, when the government has access, it's much higher. And as already said, impact of the entry and exit of new operators, this is managed in the long run when the government has access. But each country is different. Each kind of MPD project is unique. So this is giving you just a framework to discuss these things within your country. And I hope that you have enjoyed this session about data pipeline so much. Back to you, Kathy.
Thank you, Erkki. So super, thank you so much for that. I am going to end it there from a recording the session point of view. So once again, thank you so much to everybody for participating, and we'll see you next time.